Okay, average rate of change. So basically, this one is very similar to the difference quotient, except it's a little easier because you're plugging in solid numbers. So your A and B is talking about your starting and end point. So you're looking at from the f of the end point, which is your B, minus the starting point, which is 0 in this instance. So we'll look at f of, let's do 2. We'll start with this B. Just for the equation's sake, I'm using the A and the B, because you need to realize that this is the B and this is the A. Starting to end. Kind of makes sense. So that's where we go. Minus 6. Everywhere you see an X, you're going to plug in your A's and B's. So if we got 2 for the place, you're going to put a 2 there. And you can put parentheses around it because you're basically digging a hole where that X is and plopping a 2 in there. And that's going to be equal to something. Hold on. Okay, that equals negative 30. You could plug that exactly in the calculator like that and it'll tell you. So now you could say f of A, which is 0, is going to be equal to negative 6 times 0 squared minus 5 times 0 plus 4. Anything times 0 gets rid of it, so it's just 4. So now you can take the f of B, just like the formula states. That should be an f of A, not a B, and B minus A. That's going to look like this. F of B, which is 2, minus f of 0 over, and that was 2 minus 0, which is just 2. We said f of 2 equals negative 30, minus, we said f of 0 equals 4. 2 minus 0 is 2, so that equals negative 34 divided by 2, which is negative 17. That's how it works. And like I said, the difference quotient works very similar to that. It's just a lot nicer because you don't have to keep the places of the variables. You could just plug it in, solve it, and plug it in. So, good to keep in mind.